I'm G. Prabhakar, Assistant Professor of Chemistry, Department of Basic Sciences and Humanities, B.V. Raju Institute of Technology, Narsapur. And the course is Engineering Chemistry, and the topic is corrosion. Well, in corrosion, in previous two sessions, we have gone through what is corrosion. It is the destruction or decay of a metal when exposed to the environment. And there are several mechanisms are there, several types of corrosions are there. Of course, mechanism, we have dry corrosion and as well as wet corrosion that you can see in last videos, and even types of corrosion also. Okay. Now, see, corrosion is a phenomenon which every time deals with a metal and environment. So today in this session we are going to discuss about what are the factors which really affects the corrosion. So that we'll see today, that is factors affecting corrosion. As already discussed in earlier, corrosion is a phenomenon which deals with nature of the metal and nature of the environment. See, corrosion every time is related with metal and environment, because how corrosion is happening when a metal is placed in the environment. So that is the reason, obviously, factors affecting corrosion also only two factors. Number one, that is nature of metal, what type of metal that we have. Other one is nature of the environment, means it in what corrosive environment that was placed. Okay, so let us go in detail. Let us start with first nature of metal. In nature of metal, there are several features that influences under nature of metal. In that, the first one is position of metal in galvanic series, purity of the metal, then over voltage of the metal, and relative area of anode to cathode. Okay, so let us go in detail one by one. First, position of metal in galvanic series. So what is this galvanic series? See, even in electrochemistry, we have electrochemical series, where all metals are arranged based on their reduction potential values. Okay, so we go on from top to bottom, the reduction potential values increases. So here also, same like a series we have, that is called galvanic series. Okay, so like suppose there are some metal combinations, suppose if you want to say like sodium, okay, then aluminium, then iron, okay, then copper, then silver. If these metals are there, now if you want to know the extent of corrosion for these particular metals, first sodium, it shows highest, means it was easily get impacted by the environment and it easily undergo corrosion. Later comes aluminium, later comes iron. But whereas in the case of copper, it shows somewhat protectiveness towards itself to undergo corrosion, and silver is the least corroded. So, like if we have means the galvanic series, if we have observed the places of positions of these particular metals, it was like that. So these metals are positioned like this, means whatever metal which was placed top in the galvanic series undergo more corrosion, and the metal which was placed in the bottom of galvanic series, it is protected, means less corrosion. Means as we are moving from top to bottom in galvanic series, the rate of undergoing corrosion decreases. Means whatever metal which was placed in the top of the galvanic series corroded most, and the metal which was placed in the bottom of galvanic series corroded less. And even there are some conditions, there are some situations where we are supposed to use two different metals. In that perspective also, we are supposed to choose metals which are adjacent in galvanic series. like aluminum and iron or iron and carbon. So whenever two combinations if we are using, if the metals are adjacent galvanic series, obviously we can able to reduce the extent of corrosion. That is the idea. Okay, so this is about position of the metal in galvanic series. So it decides the extent of corrosion. Whatever metal which placed top in galvanic series undergo more corrosion, and bottom in the galvanic series undergo less corrosion. Means the metal top in the galvanic series undergo corrosion, and it is at the bottom it is protected. This is about position of the metal in galvanic series. And next comes purity of the metal. Yes, purity of the metal plays a major role in deciding the extent of corrosion. Like suppose if we got a 100% pure metal, then the extent of corrosion is 0. 100% pure metal doesn't undergo corrosion. But whereas if the impurity was increased by 0.01%, means if the metal is 99.99% pure, then the extent of corrosion increased by 50 times. 50 times it is. Or if it is 99.90% pure, then it was increased by 1250 times. So likewise, always 100% pure metal doesn't undergo corrosion. But whereas if any minor small impurity is present in that, it easily undergo corrosion. See here, see the difference. 100% no corrosion, but if it was 99.99% pure, means what is the percentage of impurity? 0.01% impurity is there. Then rate of corrosion is increased by 50 times. Then if it is of 0.1% impurity, then it was increasing by 1250 times. So obviously the extent of impurity plays a major role in increasing the rate of corrosion. So likewise here purity of a metal also plays a major role in deciding the extent of corrosion of any particular metal. Okay. Next comes over voltage. See, over voltage. Any particular metal inherently it contains some potential in that. So potential will be obviously measured in volts. So we are calling it as voltage. So over voltage. Suppose I have a zinc. Assume this zinc is having an over voltage of 0.6 volt. Assume. Now this zinc was placed in a natural environment. First, whatever over voltage it is having, this over voltage protect this zinc from undergoing corrosion. Immediately corrosion doesn't happen. Why? Because it should overcome this over voltage. So it will take some time. Once this over voltage was being completely exhausted, then it was started corroding. Now what happened on this zinc plate? I have placed a drop of HCl. Acid, hydrochloric acid. Now what happens? This over voltage is there, whatever over voltage, this over voltage is being taken up to overcome the corrosion from this particular HCl. So obviously the extent of undergoing corrosion increases. So in that way we can say over voltage of any particular metal is inversely proportional to corrosion. So that is the final conclusion. If over voltage is more, the rate of undergoing corrosion is less. If over voltage is less, obviously it easily undergo corrosion. So likewise, over voltage of a metal, which is also plays a crucial role in deciding extent of corrosion. And finally, last one we have is relative area of anode to cathode. Means, see, here, it is a metallic surface or metallic combinations we can say. This is a metal which acts as anode, and now it is a metal here which is acting as a cathode. Then this is considered it is as A, structure A. Then we have another one where This is anode structure B. This is anode and this is cathode. This area is cathode. Okay, so this is structure B. This is structure B. So likewise we have two, structure A and structure B. See what we observed in structure A, in relative area to anode to cathode, anode is large and cathode is small. But whereas in structure B, anode is small and cathode is large. Now, when the extent of corrosion is more, for A or B? See, obviously for B, metal undergo means in the structure type of B, the metal can undergo more corrosion comparing with structure type A. Why? Here see, anode, in the mechanism of corrosion, anode always undergo corrosion. Means always, at anode oxidation is taking place. Means suppose if it is iron, this iron wants to give some electrons, Fe plus 2 plus 2 electrons. Whatever 2 electrons which are generated, that reaches the cathode. But now here, due to this large area of anode is ready to give the electrons, but there are not sufficient electron absorbing mechanism. So obviously, the load on the metal is less. So it undergoes less corrosion. But whereas here, the cathodes are big, means the electron absorbing mechanism is big, but anodes are small. So this absorbing mechanism is going to show intensified impact on the anode. So more number of electrons it will take. So anodic metal undergo more corrosion. Okay, so that is called relative area of anode to cathode. Okay, so if relative area of anode to cathode, for better understanding, you need to write like this. Relative area of anode to cathode means anode to cathode ratio it is. So if anode to cathode ratio is small means how it becomes, means if this ratio is small means anodic area value will be less and cathodic area value will be more assumed. So now here it will become 1 by 2 means 0.5. Or if anode to cathode ratio is large means 4 by 2. So what it will become? 2. So means why I am writing these values means easily you can understand. So if the ratio of anode to cathode is small, then the extent of corrosion is more. If the ratio of anode to cathode is large, then the extent of corrosion is small. Okay, so likewise, by seeing this specific volume ratio, we can able to decide whether it undergoes more corrosion or less corrosion. Okay, means simply you observe, in denominator means if cathode area is more, obviously the extent of corrosion will be more. So that is the reason we are going to get less value. But whereas if cathodes are large, anode is small, we are going to get bigger value. So obviously, it is like we are supposed to check, means in order to free from confusion, you can remember like this. Okay, so if anode to cathode ratio is more, so when anode to cathode ratio will become more, if anodes are large, cathode is small, so it is considered as more. Then the rate of corrosion, it is less. Where here anode to cathode ratio is less, then rate of corrosion more. No need to get confused. Anode to cathode ratio is more, then rate of corrosion is less. Whereas anode to cathode ratio is less, then rate of corrosion is more. Okay, so likewise, the extent of corrosion depends on the nature of metal. On the surface, what is the area of anode and what is the area of cathode? Always, anodes area are large, cathode areas are small, then rate of corrosion is less. But whereas anode areas are small, cathode areas are large, intensified corrosion takes place. So these are the factors which respect to nature of metal that influences the corrosion. That is position of the metal in galvanic series. Obviously, whatever metal which placed top in the galvanic series undergo more corrosion. Bottom at the galvanic series always protected. Second is purity of the metal. 100% pure metal doesn't undergo corrosion. But whereas the percentage of impurity increases, corrosion intensifies. Then over voltage, always over voltage of a metal is inversely proportional to corrosion. Means if over voltage is more, the extent of corrosion is less. If over voltage is less, the extent of corrosion is more. And finally, relative area of anode to cathode. When anodes are large, cathode is small, rate of corrosion is less. Whereas anodes are less and cathodes are large, the rate of corrosion is more. This is with respect to nature of metal. Next, we move on to nature of environment. See, obviously a metal was placed in environment, then only it undergo corrosion. So in environment, what are the factors which are going to influence? That we'll see. In nature of environment, there are four key factors, that is temperature, humidity in the air, impurities in the environment, and pH. So here in nature of environment, first temperature. Temperature is always proportional to rate of corrosion. If temperatures are more, the rate of undergoing corrosion is more because oxidation takes place faster at high temperatures. So in that way, temperature is directly proportional to corrosion. So if temperatures are more, rate of corrosion is also more. If temperatures are less, if rate of corrosion is also less. Then humidity. Again here, humidity is also directly proportional to corrosion. See, we have already gone through the mechanism of dry corrosion and wet corrosion. Dry corrosion means oxidation corrosion, where it takes place in dry conditions. But whereas wet corrosion, it is going to form an electrochemical cell on the surface. So the extent rate is more, corrosion is more. Okay, so always humidity present in the air, it directly reacts with the metal surface, and the mechanism involved is wet corrosion. So obviously it undergo intensified corrosion. So humidity is also directly proportional to rate of corrosion. Then impurities in the environment, it is also directly proportional to corrosion. How impurities in the environment directly proportional to corrosion? Suppose if a metal I have placed in the environment where there was no impurities in the atmosphere. So here the possible mechanism is only two. One is if in absence of moisture, oxidation corrosion, or otherwise if any floating liquid is there, wet corrosion. Right. But whereas if impurities are present, these impurities means any gases or solid suspended particles. So these particles are going to accumulate on the surface. So thereby locally it is going to form a galvanic setup. Now this metal was undergoing corrosion due to two factors. One is oxidation, another is galvanic. And sometimes third action, a chemical reaction also. So that is the reason whenever impurities are present in the environment, it undergoes intensified corrosion. And finally, effect of pH. Generally, pH scale we already know if it is 1 to 6 acid and 8 to 14 base and 7 neutral. So up to 1 to 7 means acidic pH range, corrosion is more. So in acidic environment, corrosion takes place more. But whereas in basic environment, corrosion is less. Okay, so generally in hydrogen environment, intensified corrosion takes place comparing with the basic environment. But there are certain exceptions. Like there are some metals like, suppose if you take lead or if you take aluminium. So these are the metals. Due to this chemical nature of these metals undergo high corrosion at base conditions. So there is an exception is there. But generally, most of the metals undergo more corrosion in acidic environment and less corrosion in basic environment. Okay. So this is nature of factors affecting corrosion with respect to nature of environment, that is temperature, humidity, impurities in the environment, and pH. So temperature is directly proportional to corrosion. As temperature increases, rate of corrosion also increases. Humidity directly proportional to corrosion. As humidity increases, rate of corrosion increases. Then impurities in the environment. Obviously, polluted environment is there. It is going to form a local galvanic site. So intensified corrosion takes place. And finally, pH. Acidic environment is more corrosive than basic environment, but despite few metals show some exceptional properties due to their chemical nature. Okay. So this is about factors affecting corrosion with respect to nature of metal and as well as nature of environment. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.